In this video, we will cover how to record measurements on a part. And it will be tied to the work order. So in the future, you can look up the measurements recorded for the part by the employees during the manufacturing process. There's two ways to do this. One is simply the employee recording their measurements. The second way is by formally creating a quality plan for the employee to follow. We will cover both of those in this video. So the first way is to simply have the employees record the measurements that they make without a quality plan. To do that, they'll have their work order and they will scan the operation that they're on. And so in this case, it's laser and they would scan this barcode. And it would bring them up to this page to allow them to scan their employee badge. To record a measurement to work order 462, they would simply click this button Record Measurement. And here they have 4 different options. They can choose a normal measurement, which would be angles, diameters, depths, width, and length. They can record a pass-fail, a hole-to-edge, and a hole-to-hole. In this case, we'll just choose normal. You'll see here that it'll ask for the employee's name. And if they're what type of run or setup are they clocked in on, and in this instance, it'll be run. And they would have to know how to read the print, but they would go ahead and put in the title block tolerance or specific tolerances. And then what they are measuring. We have these quick picks over here, so we will say width of the part. And the dimension on the print is 4 inches. And they measured 4.125. Now in the title block tolerance we will put that it was a 0.0625 tolerance. So we will see now that they are measuring the width of the part. The print calls for 4 inches and they measured 4 1/8, which would be outside of our general tolerance. When the employee clicks on record, we'll see that they get a message saying stop, that the dimension was outside of the tolerance. Here we see that it was a normal measurement. And a desired 4 and the tolerance is plus or minus 0.0625, and here's your high and low range. They actually measured 4 1/8 and it's an 8-inch too big over the desired measurement, and so it's out of spec. Now we can remeasure this. Go to hole, pick Demo Admin. Again, we'll put 0.0625 in our tolerance. We'll say we're measuring width of the part. We want 4 inches, and this time we'll say we measured 4.032, which will be within tolerance. So when we click on record, we'll see that it passed. Now, we can go to the part that is in my recent list. Here is this work order 462 that we just recorded measurements on. So when I look at these orders, we will see that this link here for measured, we will see here is that failed measurement. And here is the past measurement. And so that is a simple measurement where you just ask the employees to record their measurements. Now we want to cover a quality plan where you are dictating which part of the print and the manufactured items you want them to measure. Generally, we would take the print and we would mark it up such as this. And so a 1, this bubble a 1, we want to measure this dimension here of 646. Here's dimension a 2 we want to measure. A 3, a 4 will be a pass or fail looking for burrs on the edge of the part. And then a 5 will be the distance from the edge of the part to the center of this hole. And so now we want to develop a formal plan on this. So I'll take this print here. We'll look over here, and so we see our first dimension is 646 and it's going to be a 1. So when I come over here, I'll look at the engineering master. And here is the laser operation. And I can select quality plan. And here is the quality plan for this engineering master, which is version 6. So the laser, the order will specify which order for the employee to measure, and it goes sequentially. So we'll start at 10. Remember, our bubble ID was a 1. We want them to use a 6-inch caliper. We can edit the instruments by clicking this Edit Instrument button. So we want them to use the 6-inch caliper. Now we can say that our tolerance is that we want to do. If you recall on the print, the dimension was 646. And so if our tolerance is 30 thousandths, what we're going to do here is we're going to say 0.646 minus 0.03. On size is 0.646, high size 0.646 plus 0.03. It's a normal measurement. Here is your choices. And then here we will describe the measurement. So we will say, measure the formed length on the outside. We will save the measurement. So we can see that the laser has bubble A1. And we are looking for 646, we'll accept anything from 616 to 676. And we want them to use the 6-inch caliper. So we'll continue with the next one, which is a 2, and the dimension is 423. So over here we will select that it's on the laser. Order 20, so it'll be after this order of 10, the bubble was a 2, we'll use a 6-inch mic. And this time we will put a tolerance here of 0.03. And we won't fill in low side or high side. We will just put here 0.426, I think is what we have on that print, 423. So we'll put 423 here. Then we will say the description. Then we'll save this measurement. So you see that since we had 0.03 in the tolerance, it went ahead and added the 30 thousandths and subtracted the 30 thousandths to come up with the low dimension and the high dimension. So this acceptable range is anywhere from 0.393 to 0.453. So that's bubble a 1 and a 2. We go back to our print. We now have bubble a 3, which is a hole diameter of 2.750. And, we gotta edit these two. That wouldn't be on the laser. This would be on the press brake. And we are going to edit this one and put it on the press brake. Because both of these measurements of the form would be on the press brake. But the diameter of this hole would be at the laser. So we're looking for 2.750. So we'll come over here and see we're on the sequence of laser. And the bubble was a 3. And we're gonna measure, that's gonna be order 30. So here's order 10, 20. So 30, it'll come next. And we'll have them use a 6-inch micrometer. Our tolerance is still here, and so we'll say 2.750. Measure diameter of large hole. So we could see order 30, 10, and 20. So here's the laser. They're gonna measure bubble a 3. And then we have a 4, which will be a pass or fail, looking for the burrs on the edge of the part. So we'll come over here, and this would be a laser. It's bubble of 4. And it's gonna be a visual inspection. It'll be a pass or fail. And we'll say, look for excessive burrs on part edge. K. We will save this measurement. So we can see the laser now has two measurements to do. One is measure the diameter of the large hole. Second is look for excessive part burrs. And then finally, we have this of 5, which is a hole to edge, and we're looking for 0.375. So over here in the quality plan, this would be a laser check. And we are going to use a 6-inch mic. And we have a tolerance of 0.03. We are looking for 0.375 and it's a hole to edge. Because that's what we are measuring. So now we will save this. Add the description, we will save this measurement. So now you can see we have 3 checks at the laser and 2 checks at the press brake. Now that this quality plan is in place, we will see that on the engineering master you see the quality plan is highlighted. And so we can click quality plan and see that. We can go back to the engineering master. So this deburr operation doesn't have a quality plan to it. This press brake operation does. Now when we print this work order, we will now see that the quality plan is in place here. So for the laser, here's the A3 bubble, a 4 and a 5, what they're measuring, what instrument to use, and what type of measurement it is. The frequency here is how many parts or however so many parts you want them to measure, and that can be edited on the quality plan. So if I edit this, I can tell the frequency I want every 10th part measured. And on this one here, we could say every 5. And we'll edit this one and say 10. Press price can measure every 5. And we will do 5 on this one as well. Okay, so now when we go back to our work order, we will see that it tells the operator how many parts you want to measure, every 10, every 5 and so on. So now with the quality plan in place, we will see that the operator knows that they have a quality plan to measure. Now this is where the measurement really takes shape, because again we are now at this work order here and we are going to go ahead and clock in on this laser operation. So we're going to record a measurement here. So we're going to record a measurement. Now here is our quality plan. Notice here's bubble a 3. And here is what we set up. Here is the pass or fail for A4, here is A5. Now since we clicked on laser, we are only seeing the 3 for the laser. The operator would pick their name. And a 3, they would type in what they measured for a 3. So we'll go ahead and say, for the a 3, that we measured 3.745. And then it wants to look for visual inspection, look for excessive burrs, we'll say that it passed. Now here it wants to know, using a 6-inch caliper, what's the dimension from the hole to the edge. So we're going to measure the hole to the edge, and so A5 is measured 1. So what does the caliper measure from the quadrant of this hole to the edge of the part? And so what we will do on that is we will say that we measured from the quadrant of that hole to the edge of the part, and we will put that we measured 0.270. And then it wants to know the diameter of the hole, which is measurement number 2. And you see here it's number 2. And we'll say that on this hole here, this diameter is supposed to be 200. We're gonna say that we measured 0.205. And then the operator would press the record button and they get a green thumbs up saying that the part passed. Now if we go back to the work order and scan here, and click on the record measurements, we'll go ahead and put the supervisor name there. And we'll say that we measured this dimensional one, that we measured it at 646, so we'll stay with an acceptable dimension there. Say that the part passed. And hold to edge. So here we're gonna say. So we are looking for 375. And I am going to put that we measured 0.3 and that the hole diameter is 0.201. So this time we have a failure and it tells us which places failed, and so this number 1, the diameter of the large hole, is what failed. And that's so if I come back in here and I get a chance to remeasure it. And so 0.3, so it measured 0.2. Core. And now we passed. Now when we go to the part, we will notice when we look under the order. We can click on measured, and we could see we're getting all of this in here. Now that quality plan will stay in place for that engineering master version. So you notice that we're on version 6. And so when I click on quality plan, we'll see we're on engineering master version 6. If I change, we can see that master version 5 does not have a quality plan. So each engineering master has its own quality plan, and you can fill this in as you need to, and then your operators can, by clocking into the work order. So here's the press brake operation. So when they click the barcode or scan the barcode and click on record measurement, we see here is the 2 measurements we set up for the press brake. Measure the form length on the outside, bubble a 1, and measure the flange length, bubble a 2. And so we see over here, bubble A1 is 646. So we'll come over here and we'll choose who we are. And we'll say we measured 0.650. And then A2. Right here of 423, we will say that we measured 0.420. Recorded, it passed. And now when we go to the part, we can look up the measured results of this work order and we will see that they both pass. So here is demo shipping, the employee that we just selected. And operation 475. Measure the form length on the outside, and that's what. Low, high, what is the perfect dimension, and here's what they measure. The difference is 4 thousandths. And it passed. So this is how to set up measurements for your employees to measure on the part and to be able to record it. Then for your customer standpoint, you can also print this. You can see you can print this out to include with any paperwork you need to send to the customer and really show them that you are checking your part. If you have any questions, please contact us.